Section 2.4, Managing Containers with Kubernetes. So far, you have built a web application with Spring Boot, catalog service, containerized it with cloud-native build packs, and run it with Docker. To complete the pilot project for Polar Bookshop, you must perform one last step: deploy the application to a cloud environment. To do that, you will use Kubernetes, which has become the de facto standard for container orchestration. I will provide more details about Kubernetes in later chapters, but I want you to have a first taste of how it works and how you can use it to deploy a web application. Kubernetes, often shortened as KATES, is an open-source system for automating the deployment, scaling, and management of containerized applications, Kubernetes.io. When you are working with containers in Docker, your deployment target is a machine. In the example from the previous section, it was your computer. In other scenarios, it might be a virtual machine, VM. In any case, it's about deploying containers to a specific machine. However, when it comes to deploying containers without downtime, scaling them by leveraging the cloud's elasticity, or connecting them across different hosts, you'll need something more than a container engine. Instead of deploying to a specific machine, you are deploying to a cluster of machines, and Kubernetes, among other things, manages a cluster of machines for you. I covered this distinction in the previous chapter in the context of topologies. Figure 2.9 will remind you of the different deployment targets in a container topology and an orchestration topology.
Figure 2.9. The deployment target of containers is a machine, whereas for orchestrators it's a cluster.
Before moving on, follow the instructions in Section A.3 of Appendix A to install Minikube and set up a Kubernetes cluster in your local development environment. Once you are done with the installation procedure, you can start a local Kubernetes cluster with the following command.
See this code?
Section 2.4.1, Introducing Kubernetes Deployments, Pods, and Services. Kubernetes is an open-source container orchestrator hosted by the CNCF. In just a few years, it has become the most used solution for container orchestration, and all the major cloud providers have offerings for Kubernetes as a service. Kubernetes can run on a desktop, on a data center on premises, in the cloud, and even on an IoT device. When using a container topology, you need a machine with a container runtime. With Kubernetes, however, you switch to an orchestration topology, meaning that you need a cluster. A Kubernetes cluster is a set of worker machines, nodes, that run containerized applications. Every cluster has at least one worker node. With Minikube, you can easily create a single-node cluster on your local machine. In production, you'll use a cluster managed by a cloud provider. A Kubernetes cluster comprises machines called worker nodes on which your containerized applications are deployed. They provide capacity such as CPU, memory, network, and storage so that the containers can run and connect to a network. The control plane is the container orchestration layer that manages the worker nodes. It exposes the API and interfaces to define, deploy, and manage the lifecycle of containers. It offers all the essential elements that implement the typical features of an orchestrator, like cluster management, scheduling, and health monitoring. Note: in the context of container orchestration, scheduling means matching a container instance with a node where it will be run. The matching is based on a set of criteria, including the availability of enough computational resources to run the container on the node. You can interact with Kubernetes through a CLI client, kubectl, which communicates with the control plane to perform some operations on the worker nodes. A client doesn't interact with the worker nodes directly. Figure 2.10 shows the high-level components of the Kubernetes architecture.
Figure 2.10. Kubernetes' main components are the API, the control plane, and the worker nodes.
Kubernetes can manage many different objects, either built-in or custom. In this section, you will use pods, deployments, and services. Pod, the smallest deployable unit, which can include one or more containers. A pod usually contains only one of your applications. It might also include extra containers supporting the primary application, such as containers providing additional functionality like logging or administrative tasks to run during the initialization step. Kubernetes manages pods rather than containers directly. Deployment. A deployment informs Kubernetes about the desired deployment state for your application. For each instance, it creates a pod and keeps it healthy. Among other things, a deployment allows you to manage pods as a set. Service, a deployment, a set of pods, can be exposed to other nodes in the cluster or outside by defining a service that also takes care of balancing the load between pod instances. Note: throughout the book, I will write Kubernetes resources with capital letters to distinguish them from when the same terms are used with different meanings. For example, I'll use service when referring to an application, whereas I'll write service when I mean the Kubernetes object. When you want to run a new application, you can define a resource manifest, a file that describes the desired state for the application. For example, you might specify that it should be replicated 5 times and exposed to the outside world through port 8080. Resource manifests are usually written using YAML. You can then use the kubectl client to ask the control plane to create the resources described by the manifest. In the end, the control plane processes the request using its internal components and creates the resources in the worker nodes. The control plane still relies on a container registry to fetch the image defined in the resource manifest. The workflow, again, is shown in Figure 2.10. Section 2.4.2, Running a Spring Application on Kubernetes. Let's go back to the Polar Bookshop project. In the previous section, you containerized the catalog service application. Now it's time to deploy it to a cluster using Kubernetes. You already have a cluster up and running in your local environment. What you need is a resource manifest. The standard way to interact with Kubernetes is through declarative instructions that you can define in a YAML or JSON file. I will show you how to write resource manifests in Chapter 7. Until then, you can use the Kubernetes CLI as you did with Docker earlier. First, you need to tell Kubernetes to deploy catalog service from a container image. You built one previously, catalog service 0.0.1 snapshot. By default, Minikube uses the Docker Hub registry to pull images, and it doesn't have access to your local ones. Therefore, it will not find the image you built for the catalog service application. But don't worry, you can manually import it into your local cluster. Open a terminal window and run the following command.
See this code?
The deployment unit will be a pod, but you will not manage pods directly. Instead, you'll want to let Kubernetes handle that. Pods are application instances, and as such, they are ephemeral. To achieve the cloud-native goals, you want the platform to take care of instantiating pods, so that if one goes down, it can be replaced by another one. What you need is a deployment resource that will make Kubernetes create application instances as pod resources. From a terminal window, run the following command.
See this code?
You can refer to Figure 2.11 for a description of the command.
Figure 2.11. The Kubernetes command to create a deployment from a container image. Kubernetes will take care of creating pods for the application.
You can verify the creation of the deployment object as follows.
See this code?
Behind the scenes, Kubernetes created a pod for the application defined in the deployment resource. You can verify the creation of the pod object as follows.
See this code?
Tip: you can check the application logs by running kubectl logs deployment/catalog service. By default, applications running in Kubernetes are not accessible. Let's fix that. First, you can expose catalog service to the cluster through a service resource by running the following command.
See this code?
Figure 2.12 provides a description of the command.
Figure 2.12. The Kubernetes command to expose a deployment as a service. The catalog service application will be exposed to the cluster network through port 8080.
The service object exposes the application to other components inside the cluster. You can verify that it's been created correctly with the following command.
See this code?
You can then forward the traffic from a local port on your computer, for example 8000, to the port exposed by the service inside the cluster, 8080. Remember the port mapping in Docker? This works in a similar way. The output of the command will tell you if the port forwarding is configured correctly.
See this code?
You can refer to Figure 2.13 for a description of the command.
Figure 2.13. The Kubernetes command for forwarding a port from your local host to a service inside the cluster. The catalog service application will be exposed to your local host through port 8000.
Now, whenever you access port 8000 on your local host, you will be forwarded to the service inside the Kubernetes cluster responsible for exposing the catalog service application. Open a browser window, navigate to localhost 8000/, make sure you use 8000 and not 8080, and verify that you still get the same greeting as before.
See this code?
Well done! You started with a Java application implemented using Spring Boot. Then you containerized it with cloud-native build packs and ran it on Docker. Finally, you used Kubernetes to get the application deployed to a cluster. Sure, it was a local cluster, but it could have been a remote one in the cloud. The beauty of this process is that it works the same way regardless of the environment. You could use the exact same approach to deploy catalog service to a cluster in a public cloud infrastructure. Isn't it great? In Chapter 7, you will work more with Kubernetes. For now, terminate the port forwarding process with Control-C, delete the service with kubectl, delete service catalog service, and delete the deployment with kubectl, delete deployment catalog service. Finally, you can stop the Kubernetes cluster with minikube stop.